Hello everyone, and welcome to today's webinar, Deploying MongoDB as a Service Inside the Firewall. My name is Jack Allen, and I will be your moderator today. Joining us are Chip Childers, Vice President of Product Strategy at Cumulogic, and Chris B.O., Principal Technologist and Technical Director at MongoDB. Throughout our presentation, we encourage you to submit questions using the questions pane on GoToWebinar. We will answer questions live at the end of the presentation. Please keep in mind that all participants are in listen-only mode. We are recording today's session and will email a link to the recording tomorrow and post links on the Cumulogic website. Let's get started. We'll kick off today's webinar with Chip. Chip, over to you, sir.
Fantastic. Thank you, Jack. So today, what we're going to be doing is really running through a few different topics. We're going to start with an introduction to the notion of an on-premise database as a service environment. What does that mean? Everybody understands database as a service in the public cloud, and we'll talk a little bit about what that means for on-prem or hybrid environments. Then I'm going to hand off to Chris, and Chris is going to explain what MongoDB is seeing within the enterprise, specifically around the desire for MongoDB as a service, some of the the enterprise-specific requirements that might be slightly different than the startup-style requirements. And then we'll move on and we'll talk a little bit about how Cumulogic's Database as a Service platform supports MongoDB, both within our full version of the platform as well as the Mongo-specific edition that we have available. We'll do a quick demo for you, and then we'll wrap up with Q&A. As Jack said, please do send in questions as you go, or as we go. We'll answer them all at the end. Both Chris and I will be able to answer any questions you might have. So let's start off with a discussion about what we mean when we say on-premises database as a service. So to Cumulogic, this means that you're talking about an operational automation of database delivery deployed behind the firewall for self-service consumption by developers or DBAs or anyone who needs access to a new database. Now, there's an important comment to be made here. It's not just about the delivery of the deployment of automation. It's actually about the full life cycle of the environment. Once it's been deployed, can you grow it easily? Is it being backed up by the automation solution for you? Do you have the ability to get minor version updates deployed across all of the users that are using the platform? And these are all really critical functions that move well beyond just simple automation of deployment and provisioning. So to us, that's really a key to what makes something as a service versus deployment automation. As we talk with enterprises, we've run into roughly 5 significant challenges that relate to the data side of things. The first is that there's an explosion in the number of application-specific databases. And what I mean by that is that there are lots of systems of engagement that are being built. They might be point solutions for the purpose of marketing within a line of business. Each one of those tends to have their own backend database. They might also integrate with the systems of record, but they at least have some type of state data that's all their own. And that's leading to an increase in the total number of instances. There's massive growth in overall stored data, lots of trends that lead to that. They've been going on for years now. This is really the big data revolution that we're all going through. That's a significant challenge. And then there's an increase in change within the apps that have been deployed. And that leads to an issue of how do you manage things like modifications to your schema, and that's a place where databases like MongoDB make a lot of sense. They're effectively schemaless. They allow for evolutionary design in a much easier way. Fourth, operationally supporting new technologies is always an issue for IT ops, especially when you're dealing with a DBA team that might be focused on the more traditional relational databases. There's a need to find ways to make it much easier to bring in the newer technologies that developers are interested in using, the developers are writing to, but find ways to support that team and making sure that they can really trust that the applications are, especially the back-end part of the application, is well supported operationally. And then the last challenge is really around data governance, locality, and sovereignty. This is where on-prem database as a service really shines, because when you use a public cloud database as a service option, you really do have to have a very lenient perspective around where the data is going to live regardless of the reason why you might be concerned about that, if you have something like Cumulogic in place, you'll be able to make your own choice about where you're going to deploy these systems, but you get the same operational and service experience. Database as a service is also just where it's being adopted, and this is some data that kind of came out of 451 research. It's largely being adopted where you'd expect it, both the dev and test environments, but also production web applications. And you could think of the dev test number, since it's roughly 10% greater than the production side, as being appropriate, because there's always a life cycle where you have multiple dev environments, multiple test environments. Some applications may never make it out into production. But it is really what you'd expect. These are web architectures. They might be web-based interfaces that browsers are communicating with. They might be back-end web services that make up a part of a larger environment. And then there's several other reasons for additional capacity analytics. But it is really what you'd expect. It's really around web-based technologies. Again, something that Mongo is extremely strong at supporting. Now, what Cumulogic offers is a software package that lets you deliver a on-premises database as a service environment. And if you're an IT team and you've got a large number of application teams that you support, this is really what they're looking for. And it's one of the reasons why they look to external, public cloud environments today, because it's very easy for them to say, give me the database, scale it at this size, and I don't really want to worry about any of the operational details of getting it deployed or managing it. Let that be part of the as-a-service environment. Now, if you want choice in infrastructure, this is where Cumulogic's valuable. And the analogy that we've got is Starbucks has done a wonderful job of making it very easy to walk in and get any number of caffeinated beverages. They might be anything as simple as give me a medium coffee, or it could be a much more complex soy latte frappuccino. And it's very easy for you to just go through the process of getting access to what you want at the store. And we make it just as easy to deal with database provisioning and get access to databases as a service. You start by picking your flavor. You select, let's say, MongoDB. You size it. You maybe pick some additional attributes, whether that's some add-on services, some configuration values that you might want to tune if you choose. And then you pick your infrastructure. And this could be on-prem, or it could actually be public clouds as well. And so that's how simple it is with Cumulogic, and we'll show you that with the demo. So our value for the enterprise, we believe, is really around 3 key points. First, we automate 75 to 90% of the manual operational tasks around provisioning, change, maintenance. That reduce your risks, that reduce your costs, that gives your developers quick access to multiple engines. They're fully self-serve, but you as an operations team, you get to know where the databases are running. You get to decide when infrastructure choices are made available, and even implement some policy around production maybe living in a private cloud environment, dev and test living out in the public cloud. So with that, I'm going to hand off to Chris and let him give you a little bit of a flavor for what MongoDB sees in the market today.
Thank you very much, Chip. As I get the monitor up here, I will just introduce myself a little bit. I've got a specialty at MongoDB. It's actually 2 of them. One very large field implementations going up to petabyte scale. And the second, helping our enterprise customers implement MongoDB as a service. This is where Cumulogic has become our key partner in the enterprise-specific requirements for MongoDB as a service. What do I mean by that? Well, that's what I'm going to explain. We'll start with a challenge which is brought to mind by the word cloud itself. It means a lot of things to a lot of people, but I would put it in high-level terms, as the slide illustrates, where we have a stakeholder. She could be a developer, could be a business owner, could also be someone on the operations side of databases. The net is they want MongoDB to be available right away, easily, something that will be inexpensive to use initially in development, but will not commit them to a path that won't exclude seamlessly moving in a scalable fashion to production operations. This is a key promise of MongoDB as itself as a database product, and it's something that we want to enable, continue, and extend in the cloud. All right, Getting to a little bit more specific, when we talk about cloud, typically it is divided into, well, a couple of different ways of subdividing it. Both of these are relevant to the enterprise. The first is in terms of how it's hosted. Enterprise requirements, more detail to come, typically involve something in the realm of either purely private cloud or hybrid, where public cloud is being used as part of it. For a variety of reasons, an entirely public cloud doesn't fit the requirements of the enterprise. The other way of dividing up cloud is in terms of the stack of levels of abstraction of which it's composed. At the bottom, we have the infrastructure itself, the machines or virtual machines that you're going to be using often on a per-hour basis. On top of that is the platform level, where various types of back-end software are enabled and delivered. Talk quite a bit about that because that's where MongoDB as a service comes in. It's used as a platform. And on top of that, applications are built and delivered as software as a service. So it's this middle layer of platform as a service that we're talking about, where we get advantages by implementing it as a service as opposed to just piecemeal MongoDB in terms of adoption, agility, governance, and efficiency. Let's look specifically at each of those as well as their countervailing risks. So in the enterprise cloud, MongoDB as a service provides a potential for strong rewards, above all, adoption. This has been the key to MongoDB's success in the marketplace. MongoDB has broken away from all of the other new generation databases that have come out the last 5, 10, 15 years. Clear leader in terms of adoption. And this is the core of our strategy, getting MongoDB to be used easily. Having MongoDB as a service in the enterprise makes adoption just as easy there as it does out in the cloud for an individual developer. Again, that initial vision, touch the cloud, have MongoDB available, and one of our key differentiators is that you can, even if you're new to MongoDB as a developer, have a useful app up and working in as little as 30 minutes. You can't do that, though, if you have to wait, and this is the key to adoption. Get MongoDB at your fingertips in the enterprise. We also want to match MongoDB's core asset of agility, the ability to handle different types of data, changes in the data, rapidly changing requirements. We want the infrastructure to be just as flexible with that with MongoDB as a service. Next, of course, in the enterprise, a key is governance. You want a single point in which to be able to control and also audit policy. This is a key point at which it should be done with MongoDB as a service, cloudifying MongoDB. Finally, we want to gain rewards in efficiency. We want to utilize our resources correctly. And here again, a good cloud management system is going to provide that, building up, of course, here to what Cumulogic provides. Of course, with every set of rewards, there are countervailing risks. And to be a bit hyperbolic about this for a second, cloud implementations allow you to, at enterprise-wide scope, standardize the wrong solution. You can actually ruin the entire process all at once. This is why it's critical to get it right. You want to make sure that you are using everything you need to fully populate a stack, and you're seriously considering all the decisions about how you will do this. So specifically, you can choose the wrong solution at the software level, and this is why we recommend Cumulogic, because we know it's the right one. You can also choose the wrong hardware. Most typically, with databases as a whole and MongoDB specifically, bad choices are made at the level of storage. Databases really come down to doing random writes on disk, and if you choose a storage solution that won't provide all the axes of flexibility we've talked about in terms of the storage and the random writes, no software is going to fix that. That's got to be done correctly. The next pair of errors are fundamentally economic errors. You can either price your cloud assets, such as MongoDB as a service, too expensively, in which case, to use Oscar Wilde's term, there's no limit to the number of people who can stay away from a bad opportunity. It just won't get used. Or conversely, it can be made too cheap. If there is not an effective chargeback mechanism, you tend to get a land grab. Everybody ties up resources, they aren't utilized, and there's nothing else available. I've seen this done at a level as large as an entire federal agency. So to the enterprise, our challenges are uniquely, and this is different from what you would see on the cloud in many cases, to handle the multiple hybrid infrastructures that may be brought together. In particular, software such as OpenStack, which is strongly gaining currency in the enterprise right now, traditional hypervisor systems such as VMware, whatever it is that your enterprise brings into the cloud, you're probably not going to change initially. You're going to have an enterprise stack, and you need to work with it. Regulatory requirements are going to include the governance we talked about and a particular backup. That's got to be carefully considered as you implement MongoDB on the cloud. The vision is, back to that first slide, the developer should be able to reach out, touch the cloud, and create a database on a self-service basis. However, you don't want the developers being stuck with the administrative requirements of the database. There needs to be a smooth handoff, even in the face of developer self-service, to the administrators who are going to run it in the long term. I will mention, for the moment only tangentially, MongoDB Management Service. It's a key capability of MongoDB as a company, which we provide to MongoDB as a database. There are three elements of MongoDB Management Service. First of all, monitoring. Secondly, backup. And finally, automation. The first two being a close fit. Automation actually being a recent release only a few weeks ago, something that you will see coming into use more and more. But as it's not yet available on-premise, it's generally not a factor in the type of enterprise database as a service we're talking about today. Do look for that to change over the next year. And then finally, that economic model, that most critical factor that it's easy to make either too expensive or too cheap, that's got to be worked into your enterprise's infrastructure for handling chargeback and accounting. Finally, your MongoDB as a service is going to be one of hopefully many enterprise services being stood up on the cloud. Other platforms, maybe other databases, both relational and NoSQL. My favorite situation is everything is easily available. We can compete on an equal basis with every other database out there, and I know what developers are going to choose if presented with that sort of choice. And then finally, the software as a service stack that will typically be built on top of the database platform as a service. There's also a division into three levels here in terms of how the database as a service can be delivered. As I mentioned, it may be application. That's really software as a service. It's not the platform layer that we're talking about here. There also may be a choice to implement your data as a data layer via some sort of an API interface. Again, not what I'm talking about here. This is an atypical requirement, but one good example where this has been done with MongoDB is at the Department of Veterans Affairs, their eCRUD system. The URL below will give a presentation that they gave at MongoDB World a few months ago. Then there is sort of a gray area of multi-tenancy where a single MongoDB cluster will be used by many applications, but the real focus for the enterprise is standing up a cluster per application. This could be, in some cases, for development, a singleton. In production, it will be, in many cases, a replica set. This is a high availability set, typically of 3 MongoDB servers, although it can be any number from 2 through 12. And then the second dimension, if you're scaling out for larger applications, will be sharding, in which the replica sets are still present, but there are many of them to distribute the data. That's as much as I'm going to go into on MongoDB architecture. Just suffice to say that MongoDB provides the scalability and agility in terms of high availability and scale out, and Cumulogic extends that to the cloud deployment. As we help an individual enterprise implement MongoDB, we run them through a series of choices they will make in their implementation. They need to choose what their hardware will be. Again, a key mistake can be made here, choosing the wrong hardware. How they will virtualize it for use in the cloud. How they'll handle corporate and database requirements for security. What storage will back end that server hardware. The #1 hardware mistakes, again, are made here. The operating systems they'll use, how they will manage all of their infrastructure at all of the layers. This is where Cumulogic comes in. The backup and recovery, and then that all-important accounting axis. So just to take an example, this is actually a composite built across several of our customers. This is what a given enterprise might choose for each of those. So this particular enterprise has chosen HP hardware for their servers. They're going to give two options because sometimes you simply can't determine in advance one option that's going to serve everybody. We'll either use local spinning disk or local solid-state disk to provide those higher IOPS needed for really fast web scale applications. We'll standardize on Linux. Our virtualization will be done with VMware, but for their overall cloud stack, we're going to use OpenStack. Again, this is what we see most commonly in new starts of enterprise cloud services. However, on top of OpenStack, we still need something to do the MongoDB as a service automation, and this is the key. This is where Cumulogic comes in. We'll incorporate MongoDB's own management services for monitoring and backup. Authentication, we'll use SSL standards, including public key, providing two-way authentication between the database servers and the clients. Our delivery level, as we spoke to most typically in enterprise, will be a cluster per application. It can either be a replica set, the 3 side-by-side you see there, or a shard built of multiple replica sets, that scale-out architecture that you see on the far right. Finally, for metering and chargeback, we're going to use the Ceilometer feature, which is built into OpenStack. And because we're going to deploy across multiple public clouds as well, we're going to use Union Bay networks, providing secure connection across multiple availability regions. So this is just one example. This is what we would run through in a several-day process, usually consulting with a major enterprise customer. And now I'll hand back to Chip to talk further about Cumulogic.
Fantastic. Thank you, Chris. Okay, let's pull this slide back up. So now we're going to talk a little bit more about Cumulogic, and then we'll get into a demo, so you can actually see Cumulogic, how it interacts with Mongo, and some of the key features that it's got. Cumulogic is, and I mentioned this when I started, Cumulogic is actually a software company. We sell software that lets you install this controller locally. And the controller itself then gives you an endpoint that you can use for self-service database as a service functionality. And we support a number of different technologies, some on the relational database side, some other on the NoSQL side of things. But MongoDB has been a key partner for us, and we actually have 2 different editions of our software. One of it is kind of our full enterprise edition, and that's got all the various database flavors we support. But we have a MongoDB specific edition as well, if MongoDB is the focus for you in your environment. And so that's a possibility as well. Now, to explain our service, the nearest analogy that I've got is to really look at what Amazon's RDS experience looks like. The Amazon RDS experience is one where the applications themselves are going to interact directly with a deployed database system, but RDS is going to take responsibility for provisioning and management and provide the user with some self-service functions for growing it or shrinking it. So that's kind of the key analogy that we've got. And so when we deal with our software, we've got a NoSQL service, and within that we support the MongoDB engine. This is going to give you both a web-based interface as well as a set of robust APIs. So everything you can do in the UI, you can do via API. And so that could be integrated into your application deployment tools. You could do things like auto-scaling based on the monitoring data that's being collected. And it really is very simple to deploy, and it makes Mongo deployments almost trivial for the end users. Everything from a single node to a multi-node replica set, to a development-grade sharded cluster, to a production-grade sharded cluster. And I'll show you some of those examples in a moment. In terms of features, we, again, support replica sets for actual data durability. That's both in a non-sharded as well as a sharded environment. We allow for performance optimization. We can do things depending on the underlying infrastructure. We can work with that to provide various different types of volumes being mounted to the virtual machines. We can also deal with some configuration tuning of the engine itself. Our controller will take care of automated failure recovery. And so if any node in a deployment goes offline, our controller will bring a new node back online, rejoin it to the replica set, and ensure that everything is caught up and healthy again. We do backups and restorations. We manage network access, so security and access control in and out of the cluster that's been provisioned. We do minor version updates as well, so the owner or the administrator of the Cumulogic system can take a new minor version of any database engine that's been deployed and schedule it for rollout across the course of a week for all tenants. And then I mentioned the API, a very robust API, that's generally how deeper integrations into either a broader web-based UI for for bigger service catalog work, or how some of our service provider customers actually tied into their web-based portals that they use for selling services directly. So there are a couple of example deployment patterns that our controller can make very easy for users to get access to. And I'll show you in the demo how easy it is to get these various things, but I'll just point out the different deployment patterns that we've got. Now, what I don't show is just a simple single-node MongoDB deployment, because that would be one box with some storage behind it and the application talking to it. But we can start with a single node. We can allow the user to automatically scale that up, or the user can just go ahead and directly deploy to a 3-node replica set cluster. They can also add additional nodes as their need grows. They can take that same replica set, and instead of deploying it all in one availability zone, they could actually deploy across data centers potentially. And really, when we talk about zones, we're talking about whatever level of fault domain isolation is required by you within your environment. Now, the last example deployment scenario is this, and this is roughly what it looks like for a sharded environment. And this is where you've got the application communicating with the upfront query routers. The query routers are aware of where the specific requests or whether it's a read request or a write request need to be shuttled off to, which shard it belongs to, the config servers that are tracking the overall state of the environment, and then each shard can either be a single node MongoDB instance. That's what we do for a development or test grade sharded cluster, or it could be for production grade. It's going to be a multi-node replica set for each shard. Now, the last thing I'll point out is that Chris mentioned earlier MMS. KimiLogic does provide some integration with MMS. While some of the functionality is a little bit of an overlap, Mongo has done a great job of really making sure that they've got a very deep integration to their engine for monitoring and backup services. And what Cumulogic can do for you, if you also want to leverage MMS, is that we can automatically deploy the agents into each tenant's environment on their behalf. And those agents would then be able to keep track of the environment and provide the hook back to the MMS service. So those are the slides that talk a little bit about what we do, but the best thing I've found is to actually take a look at the software itself. So this is what we're going to do now. What you're looking at is the Cumulogic dashboard. This is an environment that has both the SQL database support, and there's a couple of different engines there, as well as the NoSQL support, again, a couple of engines there. This is our enterprise version of the platform. I'll remind you again, we do have a MongoDB specific edition as well. Now, what a user sees when they log in initially, there may be some subscriptions that have been provided. In this case, let's take a look down here in the NoSQL service. We can see that there's a small database standalone MongoDB instance with a particular size of an instance and 10 gigs of storage attached, and it's going to be going off to Amazon's EC2 environment. We could just click Launch, quickly name it, and then we could choose to do some customizations if we want to, where we could, for example, tag it and say that it's a production environment, choose to enable backup services or not, and launch. That's how easy it is to get access to a Mongo instance. Now, what I did was, since I walked through the subscription model, we effectively, the administrator of this Cumulogic controller has pre-designed some configuration options. So what I'm going to do now is I'm going to walk you through the slightly more advanced approach where you get to launch a cluster and really get to see the different features that we make available. Although it's only 2 pages, so we've kept it very, very simple. So I'll go ahead and log into the, go to the launch clusters page, and we'll start by naming our cluster. We can, of course, provide a description. We select the engine. We'll be using MongoDB 249. We then select the type. This is where those different deployment options come into play. We could choose to deploy a single node. That'll be a single virtual machine, no redundancy. We could choose a replica set. Now, a replica set's going to immediately default to 3 nodes in the replica set. You could choose to make that larger, go to 4 or 5, whatever you want. Once it's provisioned, the replica set can also be grown. And the same thing applies for standalone. Once you have a standalone instance, you can use our controller and actually make it a replica set by adding nodes. It'll go from 1 node to 3, and then from 3 you can grow incrementally over time. And then last, there's the sharded cluster. Now you saw all the complexity. You've got the query routers, the config servers, you've got each individual shard needs to be configured appropriately. We've really boiled that down to a very simple selection process where you decide whether you want a dev test scale, which will not have redundancy within the shards, or whether you want production grade that will provide redundancy within the shards. And that's really as simple as it is. Then you select the cloud you're going to deploy to. In our example, we're using EC2. Our controller supports anything from anything you might find in the private cloud space, from OpenStack, like Chris was talking about. We support Citrix Cloud Platform, CloudStack, Eucalyptus. We also support vCloud Director. We have a provision that allows you to work with pre-provisioned pools of systems. They could be VMs or they could be bare metal. And we can actually leverage that pool of resources as allocatable units, deploy the appropriate application payload to it, and manage it as if it was a dynamic virtual resource that was created within an IaaS stack. But in this case, we'll deploy to EC2. It's the simplest. And because we're selecting EC2, we have a couple of instance size options. These, again, have been selected by the administrator. And so these instance sizes are really whatever the admin of the Cumulogic controller wants to expose to the users. You saw that we really only had 2 options here. Obviously, EC2 has many more. We can create a service tag. This is useful when querying for various instances across a large deployment, especially via the API. In this case, we can tag it with development. We can select a network access group, or we can leave that empty. Our controller comes with some very logical defaults. These defaults will allow you to immediately access the deployed cluster. You as a user could define your own access groups if you only wanted traffic coming from a particular subnet into any cluster you deploy, and you could apply them at this point. And then, of course, you see the total number of nodes. So we're dealing with a production environment, so we're going to see 9 nodes get deployed. Then we get to some database-specific config options, and this is where things are very Mongo-specific. So the initial question is, what's the database name that we're going to deploy? Provide a username and a password. We can create an initial collection, and when we're dealing with sharding, the question's, what are we actually sharding on? We could specify the specific key that we want to shard on. We could decide whether that key is going to be hashed or not. We can also just very easily say automatically hash on the ID attribute of the objects in the collection and let Mongo manage all of that for us. So nice and easy. We can also tweak things like character set and the port that the instances are going to listen on. So our second page, this is where we get into the kind of lifecycle support questions. So the first thing you can do is you can choose a parameter group if you want. Now what a parameter group is the way that the specific configuration options for MongoDB or whatever other engine you might be using Cumulogic to deploy can be tuned to provide various types of fine-tuning options. And you as a user could do that. The administrator can do that as well and create a number of parameter groups that can be inherited by all the users. Or we could just leave it blank and the system defaults will be deployed. And these defaults are what we've actually done the work to do quite a lot of testing with our database engine partners on. Next, we get to storage and backup services. So the question's, how much storage do we want to attach initially? We could easily just attach 10 gig volumes. That means consistently across the environment, since we selected a sharded cluster, each shard will have 10 gigs available to it. We'll be able to scale out by adding additional shards later. You could choose to enable the Cumulogic backup service as well. This is very simple. You select the total number of days to retain the backups and select the time. And then what will occur nightly at that time, our controller will take responsibility for coordinating a backup process across the cluster. We actually use Linux LVM-based snapshotting along with some coordination with the engine itself in order to very, very quickly get a backup across all the different nodes in the cluster that we need to. We compress all of those snapshots and pull them back through our controller, and we can store them either in some locally mounted file storage, or we can store them in an object store like OpenStack Swift, or even out to Amazon's S3 environment. Next, we can select a maintenance window. This is going to be used primarily for minor version updates. So when the admin of the Cumulogic controller wants to roll out a new minor version of, let's say, MongoDB, every deployed instance that's out there will get scheduled for an update over the course of a week. And the end user can actually decide when their maintenance window is going to be by selecting the day of week and also the start time for any potential maintenance activities. So then the operator only has to say it's going to be this week and then inform everybody, and then they'll know that over the course of that week when their maintenance window hits, that's when their instance is going to go through the upgrade process. And with that, I would click Submit. It would go through the provisioning process, but to keep the webinar short, we're just going to jump back to some clusters that I deployed just prior to us kicking off the webinar. And what we can see here is that we've got two different deployed environments. The first one is a sharded cluster. This was set up as a dev test scale sharded cluster, which means we're dealing with single nodes within each shard, as opposed to replica sets within each shard. And then we also just have a straightforward replica set environment where you've got 3 nodes deployed. And some of the things you can do for a replica set based clusters, you can modify some things like the parameter group. You could restart the whole environment. You could terminate it, which will shut everything down. Or you click Add Nodes, and it's going to add one additional node. It would go from 3 to 4. The last thing we can do is we can clone. Now, cloning is useful because it will actually take a backup of that particular database at the time you request the clone, and then it will provision a new copy, equal configuration to what you started from, and then load all of the data from that backup into the new environment. Very, very useful when you think about the application lifecycle. If you're about to roll out a new version of your application and you want to do one last smoke test of the functionality prior to the cutover, you want to do that using production data. So you can clone your Mongo environment, point your staged copy of the new app to that environment, do your smoke test, and then once you're comfortable, repoint it over to the production environment, and then, of course, very quickly terminate and delete the clone that you had created. Over on the sharded cluster, the actions become slightly different. Let's wait until this in progress job is done. Well, what you can do with the sharded cluster is instead of adding additional nodes to the replica set, you can add entirely new shards. And so for a production environment, when you add a new shard, it would be a 3-node replica set, including Arbiter, and you can take a look at that here. So you can add a shard that'll grow, but you get some of the exact same functions you got with the replica set, right? You can modify the config, you can restart the whole environment, kill it off by terminating, or you can clone the whole cluster. Now, within the tabs down below, you're going to see a few tabs that are interesting. One is the Events tab. This is going to show you everything that's occurring within our controller on behalf of the user. These are HA monitoring jobs. This is the backup routines that are occurring. It's also all of the provisioning steps that might have occurred during the initial provisioning run, as well as anything that might happen because of a self-service call to grow the cluster or take a snapshot on demand. Access details, this is going to get you visibility into the actual deployed nodes that make up that underlying architecture. We can see here we've got one query router, here's the IP, we've got the config server, we also have one shard, and within that shard there's one node. With a production environment, you would see within one shard multiple nodes, again including the arbiter. Next, we can take a look at the collections that are actually within the Mongo database itself, including some things like total number of documents, data size, and total size. This is useful just for some visibility for capacity planning reasons. And last but not least, we have some visibility into the users that are supported or that have been deployed into that environment for you. I'm going to jump over to the snapshots. These are as you'd expect. These are backups of any cluster that's been deployed, including all the data. And from here, you can either create a snapshot on demand. You do that by selecting the database cluster that you want to create the backup of, and then naming the snapshots. You can see both of my deployed clusters are right there. You'd name your snapshot, you'd say create, and we'd go through the process of doing the creation. You can also restore from a snapshot. Now, when you restore from a snapshot, you take an existing snapshot. That's going to have a copy of all the data that's there. You name a new cluster. You, again, select the zone you're going to deploy to, the size, the storage you want to attach, potentially port and some other config values, and click Restore. And then what it's going to do is instead of replacing the data in the environment that the snapshot came from, it's going to create a new cluster for you. And so then you can double check that what you've backed up is what you want, repoint your application to it, and then go kill off the original cluster that you were working with. Last tab before we switch over and we get back to the Q&A. We do support some level of monitoring. Now, what this is for Cumulogic is a combination of monitoring of each one of the virtual machines, relevant operating system level metrics like CPU utilization, memory, but we also then, depending on the engine, in this case Mongo, we'll have some specific parameters that are useful for that engine. And so you can see, for example, come down here, we can see total number of operations, total number of reads. For any one of these metrics, you can drill in, you can change the total duration that you're getting visibility into. Now, I did mention that we have some hooks into MMS. That, of course, allows you to deploy the MMS agent. That would mean that the MMS agent is able to report back to the MMS service, and that would provide for monitoring and backup functionality that MMS provides. But we also support two other external monitoring solutions. One of them is AppDynamics, and the second is New Relic. Our controller is able to allow the users to register their keys with the Cumulogic controller, and then as every environment is deployed, every cluster is deployed or every node is deployed, we're automatically registering that with AppDynamics and New Relic. You get the benefit of full stack monitoring with those types of services because you might be deploying your application servers or your web servers via some other mechanism, but you're going to get the single view up and down your application stack when you use those external services. So with that, we're going to switch back over here to the PowerPoint, and we'll go ahead and see if there are any questions. So, Jack, have we got any questions from the audience?
Yeah, thank you, Chip and Chris, for your presentations. We do have some questions. Audience participants, thank you for submitting your questions through the question pane, and I encourage you, if you have additional questions, to continue to put those into the questions pane, and we will get them asked. So the first question is related to Cumulogic. Chip, what approach is Cumulogic taking to multi-tenancy in the platform?
Yeah, great question. There are really two parts to that answer. The first part I didn't spend a lot of time on, which was discussing the various level of integration we have with the underlying infrastructure as a service environment, whether it's public cloud or private cloud implementations. Now, I did mention that we talk to a number of different APIs. That means we can work with the OpenStack environments. We can work with anything that's CloudStack based, anything vCloud Director based, as well as, of course, Eucalyptus, and that means we, as we saw in the demo, work with EC2 as well. Now, that provides us with the ability to allow each user within the Cumulogic environment to actually have their identity mapped down into the infrastructure as a service platform. And so that means that I can come in and I can put my EC2 API credentials into the Cumulogic controller, and every database that I ask from Cumulogic will be deployed within EC2 as me. And so you get all the multi-tenancy characteristics of that underlying infrastructure as a service environment, then apply to the solution. The second layer of the answer is that our controller is designed with, of course, multi-tenancy in mind. We sell to both service providers as well as the enterprise. And in both of those environments, multi-tenancy is very important. And so each individual user is responsible and only able to see the databases that they've requested. We do have some role-based access control functionality that's available via our APIs. And then the administrator, of course, can get visibility across the entire estate. And they can do a better job of kind of managing across all their users.
Wonderful. Thank you, Chip. We have another question. Actually, we have quite a few more questions. Thank you, participants, for submitting. Again, this is related to Cumulogic. What are the infrastructure requirements to make this solution work?
Well, conveniently, I think I just ran through those. So again, we'll work in a large number of different environments. I talked about some of the private cloud software that we can integrate with. We don't have a lot of requirements of that infrastructure other than available capacity. We need to be able to provision virtual machines and virtual volumes that get mounted to the virtual machines. We also need some network access from our controller into that environment. That's really kind of at the core of what we need. What we did also talked about earlier, that we support provisioning against a pool of pre-provisioned systems. And when we say pre-provisioned, this is really kind of an important thing, because we don't mean that they're pre-provisioned with Mongo engines deployed. All we need those pre-provisioned systems to be are a plain vanilla CentOS-based Linux distribution installed. The systems need to be on the network, and we need to have the appropriate access credentials to log in and take ownership, or our controller needs the access credentials to log in and take ownership. So what that means is that you've got a lot of flexibility really in the types of hardware that you might choose to use. You have a lot of flexibility in potentially multiple options for how you want to have these databases be deployed. Our controller can work with up to 20 different target clouds, and a pre-provisioned pool of systems would be one of those target clouds. We can also service thousands of virtual machines within each one of those target clouds from a single controller. So hopefully that answered the question.
Wonderful, wonderful. Thank you, Chip. Here's a great question. Why is the developer given control to provision rather than the DBA? How many of the developers know what they are doing?
That is a really good question. So the way I'd answer that is I would say that within an enterprise you have a couple of different choices about how you use this. You could look at this as a DBA automation tool, certainly. And that means the DBA team could take responsibility for clicking a couple of buttons in order to get each system deployed. And that's certainly a very viable approach. Some of our customers actually take that approach. They see this as really an automation enabler for the DBA team. But when you look at the way public clouds are offering database as a service today, there's a demonstrated expectation right now that developers have where they expect to be able to get complex solutions on demand immediately via self-service or even via API calls. And so what that means is that if you think about a developer that's working, let's say, within a line of business in your organization, they've been tasked with standing up an application environment for, let's call it a marketing website. It might be a short-lived campaign. It might be maybe a 6-month campaign or a 6-month-long site that's going to be out there. They really expect that not only can they get the virtual machines on demand, and if you as an IT department have implemented a private cloud, they would get them there. But they also expect that they can get a database on demand at that slightly higher level of abstraction. And again, the public cloud adoption of things like RDS and the various public MongoDB-as-a-Service options that are out there really are resonating with the developers because it's a couple of clicks and they get what they need. So there's no waiting for a DBA to get to the ticket. Now, oftentimes DBAs then would say, well, I mean, it's kind of automating me out of a job, right? And the answer to that is absolutely not. You become even more valuable at that point. Anybody who's an expert in the data layer of the application stack shouldn't be spending their time doing things that are automatable, that can be handed off to the application teams in a self-service way. You should be elevating the way you spend your time to being much more valuable for those application teams. You should really be a key resource for the app development teams as they navigate the data landscape of your enterprise, pointing them at maybe pre-existing sources of data, working with them on best practices for using the engine that's been deployed, making sure that that maybe the edge conditions that the Cumulogic platform don't cover are handled, that you can get into the engines and tweak things. So you as a DBA want to be elevating yourself above the work that can be repeatably automated, regardless of whether we're talking about provisioning, change, or decommissioning. That whole life cycle can be automated, can be made self-service, and so there's a lot more value if you spend your time getting to know the application teams at a higher level.
Yeah, I think that's well put, Chip. At the end of the day, Cumulogic's benefit and value prop is taking the repetitive task of installation, various architecture, zone deployments, putting that in the hand of the consumer, and exactly as you said, allowing the database administrator to really be focused on more strategic, directional activity versus the ongoing mundane, not always mundane, but deployment activity and ongoing support activity. Chris, a question for you. What type of applications are MongoDB most frequently used as the database for?
Jack, thank you very much. It actually goes to the key advantage of MongoDB in agility. If you'd asked me the inverse of that question, I would have had a hard time answering it in terms of what is MongoDB not used for. The flexibility of MongoDB's document-based data model really puts it beyond the traditional realm of the relational database. So new starts of projects that get to pick a database are more commonly than not choosing a new generation database, where MongoDB has far and away been the most predominant. And for that matter, relational implementations that have hit brick walls in terms of their ability to scale or to handle agility as data changes have also been moving to MongoDB. Just to give some categorization, we tend to break our use cases into a handful of the most common we see: big data, content management, customer data management, in particular single view of the customer aggregating multiple systems, database as a service, as we're talking about here today, although of course each individual implementation of that would fit into one of the use cases, Internet of Things, mobile applications, product and asset catalogs, security and fraud applications, and perhaps for sheer number of implementations, given that we have one customer implementing MongoDB as a service for over 270,000 individual apps, social, and collaboration.
Wonderful. Thank you so much, Chris. Audience, we are down to the last 2 or 3 questions. If you have any more questions that you want to submit, now would be a great time to do so. Here is one that we did just receive. Can you also deploy on Azure? Chip,
yeah, great question. Yep. Yeah, so we don't support the Azure APIs yet. It's on our roadmap. It's actually coming very soon. There are some ways that you could do that. Like I mentioned, the pre-provisioned pools of systems. If you thought that the kind of ongoing support was useful, you could provision ahead of time the virtual machines on Azure, and then allow KimiLogic to use them as if they were kind of an on-prem virtual machine or bare metal pool. But we are actually going to be adding the APIs that allow us to create virtual resources during the provisioning process within Azure very soon here. We've seen a significant jump in interest in Microsoft Azure. Up until recently, to be frank, most of the public cloud discussions were revolving around EC2 mixed with some sort of private cloud environment. But now we're much more frequently seeing, than we were previously much more frequently. We're now seeing a lot of demand around Azure. So you can expect that from us fairly quickly. We've architected our solution so that each new API that we support is actually kind of a plug-in to our core framework, which means we can develop them rather quickly. And so we'll put that update out as soon as we have it available.
Thank you, Chip. Follow-on question by the same individual. Sir, thank you for submitting. can you archive in cold storage, in the Amazon environment?
That's a good question. No, we don't have any specific hooks to archive for cold storage in Amazon. Now, I guess there are a couple of different ways you could think about Amazon. So there's the Glacier service, which is for really long-term data retention, extremely cheap, very difficult to get the data back out. We don't support the Glacier APIs today. What we do support is the S3 APIs, and so any of the snapshots that are being pulled back could be pushed off to S3. That would give you a possibility to then kind of take those snapshots, maybe through a secondary job, move them to Glacier, and then our controller would go back through and when the retention period was over, clear the snapshots out of S3 for you. So that would be a potential option for it.
Wonderful. Thank you, Chip. Here's a question that I know there's been a lot of discussion internally at Cumulogic. Are you supporting database deployment using Docker containers?
Yeah, very good question. So today we don't actually do that via Docker containers. The unit of isolation right now is the operating system. Our engineering teams are currently going through the process of designing how we can modify our architecture to use Linux containers. Docker is most likely the container technology as a way to make the unit of isolation much smaller. Now, within an IaaS environment, it's possible that we'll end up with still the model of creating a single virtual machine for each node of a particular cluster. You want that for some level of isolation. But where we think the Docker approach will help us is if we're dealing with these pools of pre-provisioned systems or bare metal servers, and then we'll be able to use that as, instead of each larger system being the unit of deployment, we'll be able to carve them up and then take a cluster that's being deployed, and if it's only going to be small nodes in the cluster, we can still push to to multiple bare metal servers, and perhaps there are 3 clusters living on the same 5 servers. So we don't do Docker today, but it is going to be something that we use underlying inside of our product itself as a way to kind of enhance how we deal with bare metal provisioning, and then we'll have a consistent experience across both the on-demand virtual machines and the pre-provisioned systems.
Thank you, Chip. And the last question, which I can handle myself, it is, will this webinar link be posted or emailed out? The answer to that is yes, it will. We will be emailing out the webinar link to those that participated. We will also provide the link on our website. With that, we conclude all the questions. Thank you for submitting. It was a very good list of questions. If you're interested in more information related to Cumulogic and our database as a service, you can actually request a sandbox at cumulogic.com/sandbox, or if you want more additional information or have more general questions, feel absolutely free to email us at info@cumulogic.com. On behalf of all of the presenters and everyone joining us today, I want to thank you for your time, and it's greatly appreciated. We certainly look forward to follow up an additional conversation wherever you're at in the world. Thank you for joining. Have a great day or a great evening, and goodbye.